Eaton Fuller Easy Pedal angle spring clutches are made up of 4 major components: the cover assembly and 2 driven discs separated by an intermediate plate. These heavy-duty clutches are pull-tight, dry disc design. In service, mechanical adjustment is required periodically and is facilitated by Fuller's Quick Adjust mechanism. Easy Pedal 2000 models feature the 6-point Quick Adjust mechanism and power thread technology. 3 pairs of angle springs are equally spaced around the clutch cover to reduce the pedal effort required when engaging and disengaging the clutch, ensuring a constant plate load. 3 additional springs are designed to facilitate disengagement and reduce overall pedal effort. In all Eaton Fuller heavy-duty clutches, the springs are isolated from the direct heat of the pressure plate and are angled. Eaton's 15.5-inch clutch has a positive separator pin that improves clutch life and performance by providing cooler operation, smoother engagement, and equal plate separation. The separator pin allows the intermediate plate to move back when the clutch is released, giving constant gap on both sides of the intermediate plate. Driven discs are available with organic or ceramic facings. Organic facings are for medium-duty highway use, while the ceramic facings are for heavy-duty highway or off-highway applications. The life of a clutch is increased by using ceramic-faced driven discs. Driven discs may be furnished with a rigid or dampened type hub. The dampened type is recommended because of its greater capacity to absorb shock, control torsional vibration in the drivetrain, and reduce spline wear to the transmission input shaft. In extra heavy-duty applications, coaxial springs are used. Coaxial springs are springs within springs which additionally reduce shock and control torsional vibration. Major components of a typical 15.5-inch cover assembly are Fuller's exclusive positive separator, the pressure plate and levers, pressure plate return springs, exclusive internal assist springs, cover, adjusting ring, pressure springs, release bearing, release sleeve, and quick adjust mechanism. 14-inch clutches use a different intermediate plate, pressure plate, clutch cover, and driven discs. All other components are the same as in the 15.5-inch clutch. On most non-synchronized transmission applications, you will want to install a new clutch brake. Clutch brakes help drivers shift into first or reverse without transmission damaging gear clash. They ensure smooth shifting and are only activated when the driver pushes the clutch pedal to the floor. It should be noted that clutch brakes should never be used for upshifting. Fuller offers 2 types of clutch brakes: the 2-piece Quick Connect model, which can be installed without removing the transmission. Brakes are also available as single-piece torque limiting models. We recommend the torque limiting type because it's designed to slip when heavy loads are reached and therefore extends its service life. Eaton Fuller clutches should be replaced when adjusting cannot correct for a loss of free pedal or cannot compensate for a slipping clutch. If clutch replacement is necessary, the transmission must be removed. When removing the transmission, use a sling or jack to maintain alignment. Don't let the rear of the transmission drop, and don't let the transmission hang unsupported on the spline hubs of the driven discs because it distorts them and could cause poor clutch operation or clutch release problems. Taking these precautions will prevent bending and distortion of the clutch discs and ensure trouble-free performance. Before pulling the transmission free, disconnect the external clutch linkage and turn up the release yoke so it will clear the release bearing when it is removed. Carefully pull the transmission back to remove the spline shaft from the driven discs in the clutch. Install a spline aligning tool in the release bearing in the driven discs. You can use a transmission input shaft for this purpose. Pull the bearing back using the release tool shown and insert 2 5/8-inch spacers between the flywheel ring and the release bearing housing. The spacers relieve the heavy internal spring load of the clutch cover and allow for reinstallation. Completely remove the top 2 bolts and install 2 guide studs. Take out the remaining mounting bolts and carefully remove the clutch. You may want to use a hoist to do this because 14-inch clutches weigh approximately 75 pounds and a 15.5-inch clutch installation weighs approximately 150 pounds. Now that the clutch has been removed, the following inspections must be made. Inspect the mating surfaces of the transmission clutch housing and the engine flywheel housing. Any appreciable wear on either housing will cause misalignment. Most wear will be found on the lower half of these surfaces, with the most common wear areas between the 3 and 8 o'clock positions. Replace the clutch housing if it is worn. Begin by wiping all surfaces before gauging. Secure the dial indicator to the engine flywheel housing with the gauge finger on the face of the flywheel near the outer edge. Rotate the flywheel or crankshaft. For an easy pedal clutch, the maximum allowable runout is 0.8 of an inch. Move the gauge finger to contact the pilot bearing bore surface. Again, rotate the flywheel. The maximum total allowable runout is 0.5. If any of these limits are exceeded, the problem must be corrected or misalignment will cause premature wear to the drivetrain components. Next, secure a dial indicator to the engine flywheel or crankshaft and put the gauge finger against the housing pilot. Rotate the flywheel or crankshaft. Use a marker or piece of soapstone to mark the high and low points. The total indicated difference between the high and low points must be 0.8 or less. Move the gauge finger to contact the face of the engine flywheel housing. Again, rotate the flywheel or crankshaft and then mark high or low points. The total runout should not exceed 0.8. If any of these limits are exceeded, the problem must be corrected or misalignment will cause premature wear to the drivetrain components. Loosen the bolts, remove the flywheel, and set it on a work surface. Remove the 2 set screws from each of the drive pins. Since the drive pins are made of hardened steel and could chip, wear safety glasses when removing old drive pins. Drive out the old drive pins. Install 6 new drive pins in the previously unused hole in the flywheel. Space them out equally. Make sure that the shanks of the pins are a press fit in the flywheel rim. We recommend using a drive pin alignment tool like the one you see here from the Fuller CSK1 toolkit. Make sure that the heads are square with the friction surface. Put 2 small spacers on the friction surface of the flywheel and carefully set the intermediate plate over the drive pins. The spacers will prevent getting your fingers pinched by the intermediate plate and give you a finger hold when removing it. Turn the intermediate plate in one direction as far as it will go. Use a 0.6 feeler gauge and check the clearance between drive pin and the drive slot. Check the same side of each pin. The minimum clearance between the drive pins and the drive slots is 0.6. If the proper clearance is not obtained, recheck the drive pins for squareness and realign if necessary. Then recheck the clearances. This check is necessary to ensure that the clutch will release properly when installed. Do not file the drive pin slots on the intermediate plate to obtain correct clearances. Doing so will cause an unequal load on the pins. This is a frequent cause of poor release or the clutch not releasing at all. It also can result in broken drive pins. If the alignment and clearance are okay, lock the pins in place with 2 new 3/8 inch by 3/8 inch set screws. Reinstall the flywheel to the engine crankshaft, making sure the chalk marks are lined up. Refer to the engine manual for torque specs. Remove the pilot bearing and replace with a new bearing. Caution: tap on the outer race of pilot bearing only and make sure it is seated properly in the bearing bore. This bearing must have a press fit. Place the front driven disc against the flywheel with the side stamped flywheel facing the engine. Next, install the intermediate plate by positioning the drive slots on the drive pins. Caution again, Super Duty clutches have thicker intermediate plates and thinner super buttons than standard clutches. Do not intermix these components. If you are installing a Super Duty clutch, be sure to install 3 anti-rattle springs. Space them equally between the drive pins with the rounded sections towards the flywheel face. Because cuts could result from sharp edges, you should wear heavy gloves when installing anti-rattle springs. Insert the aligning tool through the hub of the rear disc with the side-stamped pressure plate facing the transmission and install it behind the intermediate plate. Remember, for proper fit, it's imperative that the side-stamped pressure plate faces the transmission. Insert the aligning tool through the hub of the front-driven disc and into the pilot bearing. The relative position of the buttons on the front and rear discs is not important. Position the clutch cover over the guide studs installed at the top of the flywheel. Make sure that the quick adjusting mechanism is aligned with the opening in the bell housing of the transmission. Start 6 3/8 by 1 1/4 inch grade 5 or better mounting bolts with lock washers and tighten them finger tight. Remove the guide studs and replace them with bolts and lock washers. Tighten the bolts in a crisscross sequence to pull the clutch into its proper position in the flywheel pilot. You must start with the lower left-hand bolt. Failure to tighten the bolts in this manner can cause permanent damage to the clutch cover or create an out-of-balance condition. As the bolts are tightened, the wooden spacers should fall out. If they do not fall free, be sure to remove them. To achieve the final torque, progressively tighten all bolts to 35 to 40 foot-pounds. You may have to lightly tap the aligning tool with a mallet to remove it. Installation of the 14-inch clutch is now complete. Reinstallation of the transmission and the adjustment procedure will follow the section on installing 15.5-inch clutches. When installing a 15.5-inch clutch, rotate the flywheel to level the 2 guide studs. Insert the aligning tool through the release bearing sleeve in the new clutch. Put the rear driven disc on the tool with the side stamped pressure plate facing the pressure plate. Place the intermediate plate in the clutch cover and align the driving lugs of the plate with the slots provided. The positive separator pins must be flush on the pressure plate side. Install the front disc on the aligning tool with the side-stamped flywheel facing the engine. Remember, it's imperative that the side-stamped flywheel faces the engine. The relative position of the buttons on the front and rear-driven discs is not important. Make sure that the quick adjust adjusting mechanism is aligned with the opening in the bell housing of the transmission. Position the clutch over the guide studs and slide it forward. A 15.5-inch clutch weighs about 150 pounds, and a hoist may be required to lift it into place. Start 6 7/16 by 2 1/4 inch grade 5 or better mounting bolts with lock washers and tighten them finger tight. Tap the aligning tool to make sure it is centered and seated in the pilot bearing. Remove the guide studs and replace them with bolts and lock washers. Tighten the bolts in a crisscross sequence to pull the clutch into its proper position in the flywheel pilot. You must start with the lower left-hand bolt. Failure to tighten bolts in this manner can cause permanent damage to the clutch cover or create an out-of-balance condition. To achieve the final torque, progressively tighten all bolts to 45 to 50 pounds-foot. You may have to lightly tap on the aligning tool with a mallet to remove it. Using a flat end 1/4 inch diameter punch, lightly tap each of the 4 positive pin separators toward the flywheel. After tapping, the pins should be flush against the flywheel. Installation of the 15.5 inch clutch is now complete, and you're ready to reinstall the transmission to the engine. To reinstall the transmission, shift it into gear. When installing the clutch brake, be sure to install it on the input shaft against the face of the transmission after checking for excessive bearing cap wear. Check for wear on the fingers of the clutch release yoke. Also check the cross shaft and cross shaft bushings. Replace them if necessary. Check to be sure that neither cross shaft protrudes through the release fork, since this could cause side loading of the release bearing. Make sure that the transmission is square to and aligned with the engine when it is raised into position. Lift the release yoke so that it clears and is rotated over the wear pads of the release bearing as the transmission is moved forward. Be careful. The release yoke fingers must not be elevated to the straight out position. They would damage the clutch cover when moving the transmission forward. Move the transmission forward, but never, and we repeat, never, force the transmission into the clutch or flywheel housing. If it doesn't enter freely, investigate the cause and make adjustments until it does. Don't let the rear of the transmission drop, and don't let the transmission hang unsupported on the spline hubs of the driven discs because it distorts them and could cause poor clutch operation or clutch release problems. Taking these precautions will prevent bending and distortion of the clutch discs and ensure trouble-free performance. Mate the transmission with the engine housing and install the housing bolts. Torque the bolts to the proper manufacturer specifications. Attach the clutch release linkage. Installation of the transmission is now complete, and adjustments can be made to the clutch. To help you better understand the clutch adjustment procedure, the following terminology should be understood. Release travel. Proper release travel assures that the release bearing is capable of releasing far enough, allowing the 2 driven discs to spin freely, avoiding clutch drag. Clutch free pedal. Pedal free play is an indication of clutch adjustment interval. When free pedal is no longer present, adjustment is required. Clutch free travel. Free travel is the clearance between the release yoke and clutch release bearing wear pads. This dimension regulates how much free pedal is obtained in the cab. Clutch brake squeeze. Proper clutch brake squeeze assures that the input shaft will stop rotating when the vehicle is stationary. A clutch brake is only used when shifting into first or reverse gear. Keeping clutch brake squeeze close to the end of the pedal stroke helps to assure that it will not be used as an upshifting brake, causing brake life reduction. The following is a brief explanation of adjustments. Normal service internal clutch adjustment. Clutch component wear is adjusted internally in the clutch through clockwise rotation of the adjusting ring. This adjustment moves the release bearing toward the transmission and reestablishes the 1.5 inch release travel and 1/8 inch free travel. Linkage adjustment. Linkage adjustment should only be performed in the following 2 cases. First, during initial dealer preparation to set total pedal stroke and yoke throw. And second, to compensate for linkage wear, clutch brake wear, transmission bearing cap wear, or replacement of relative clutch or linkage components. Now we are ready to begin the adjustment procedures. With the pedal in the up position, measure the distance between the back of the release bearing and the clutch brake. The release travel distance should be 1/2 to 9/16 of an inch. If not, adjust the clutch internally to obtain this dimension. In order to turn the adjusting ring, fully depress the clutch pedal. For easy pedal quick adjust, insert a 3/4 inch 12-point socket or 3/4 inch boxed-in wrench and depress the square-headed bolt to adjust the clutch. Rotating the adjusting ring clockwise will decrease the release travel dimension, and rotating the adjusting ring counterclockwise will increase the release travel dimension. When 1/2 to 9/16 inch dimension has been achieved, assure the quick adjust is in its locked position. The flat on the bolt head will align with the flat on the bracket. Verify 1/2 to 9/16 inch dimension when the pedal is in up position. Now adjust the external linkage to obtain the 1/8 inch free travel dimension. This is the distance between the release yoke and the release bearing wear pads. Proper adjustment of the free travel should correlate to a free pedal in the cab of 1.5 to 2 inches at the top of the stroke. Consult OE manufacturer's service manual for exact free pedal dimension. Check that the clutch brake squeeze begins when the clutch pedal is 1/2 to 1 inch before the end of its stroke. To check this, insert a business card or similar 10/1000 feeler gauge between the release bearing and the clutch brake. Depress the clutch pedal to the end of the stroke and squeeze the card. Let the pedal up slowly and stop when the card can be pulled out. The pedal position should be 1/2 to 1 inch from the end of the pedal stroke. If these dimensions cannot be obtained, review your OE manufacturer's service manual or contact your field representative. 1/2 to 9/16 inch release travel, 1/8 inch free travel at the yoke, 1/2 to 1 inch clutch brake squeeze from the end of the pedal stroke. After completing the clutch and linkage adjustments, lubricate greasable release bearings with a recommended high temperature lubricant. Sealed bearings do not require additional lubrication. See your Fuller service manual for recommended lubricant types and manufacturers.